So I want to thank Wasim Villidad for pointing out a rather nice way to find the square root of a complex number. So start off by saying root minus 5 plus 12i equals a plus ib, like as suggested in the question, and what I like to do as well. And then you square both sides. Minus 5 plus 12i equals a squared minus b squared plus 2abi. And what I usually do is I form two equations here, minus a squared minus b squared equals minus 5, and then ab equals 6. But what he suggested is I don't do that I just take the first equation and then form a second equation slightly differently. So the second equation I can get by looking at the magnitude, the modulus. So the modulus of root minus 5 plus 12i is equal to the modulus of a plus ib. If you square both sides, then what you have here is the modulus of minus 5 plus 12i equals the square root of a plus ib, the square root of a squared plus b squared squared. So that cancels the root there, and that is 13. So you get 13 equals a squared plus b squared. And those two equations are much nicer to work with than what I was doing previously. If you add these together, then you get 2a squared equals 8. So a equals plus or minus 2, because a squared would be 4. And then if you sub that in, say here for example, you get b squared equals 13 minus a squared. So b equals plus or minus 9. So the answer, a plus bi equals plus or minus 2. Oh, do you know what? And I forgot, that's b squared. So b is plus or minus 3. So that's 2 plus 3i. And that's the answer. And that's, you can do that, you can do it this way to avoid producing a quadratic equation. So it's a little bit more to the point. If we want, we can check the answer. So if we square this out, we'll get 4 plus 12i minus 9, just minus 5 plus 12i. Yeah, so that works out. And it doesn't matter if the minus is here, because when you square it out, the minus is gone. So this looks correct. So again, thank you for that. I'll probably stick to this technique in future when these questions come up. So much appreciated.